I think maybe, would you say we start at least for the beginner, like for the first 10 or so slides, we don't need the network while that gets figured out.
Yeah, that's.
I'm connected through my phone, so that's.
Also, they will get from.
Yeah, people who are not here.
Okay, awesome.
Okay, so
yeah, let's start it.
So I mean, we already welcome each other many times, so I'll skip that. But certainly, the goal and the audience, it is a mix. Of course, data science will be a core of the workshops, but the first 4 or so will be more geared towards data engineering. Certainly, to get to data science first, you need to have proper data engineering, have making sure that the data makes sense, making sure that you know how to transform data sets, etc. But in general, related, the audience is big data people that are interested, maybe not necessarily so technical, but once you get their hands dirty and actually do hands-on work. So what is the objective of the workshops? Well, the main would be to learn data science and data engineering using Apache Spark. Apache Spark is a framework that in the last few years have grown quite a bit. So I'm sure if you guys are here, I'm very sure that you heard it at this point. The workshop will be based on some workshops that were given by Databricks through the EDX platform. So we use that as a base. In fact, the videos for this week were the ones that were used for delivering the sessions, the EDX sessions. And one important thing is that we expect you to complete the material and weekly challenges. So this week we are there's really not much to submit, but from other weeks there will be a lab that you would complete. And sometimes you will be asked to submit that lab. Sometimes there will be an exercise that goes together with the lab that you would complete. The labs will be more, I would say, guided in the sense that there are clear instructions, fill in the code in this section and making sure that everything from there down works. Exercise will be more open-ended in the sense that there will be a statement, for instance, starting from this data set, transform this data set, do some sort of cleaning, do some sort of transformation. And the idea of not having precisely step-by-step instructions on those is because we think that that is the sort of problems that you will find when you go work when you do actual work, which is you have a problem, but you don't necessarily know how to solve it, so you have to go about it. You have to go find out what is the best way, what are the proper techniques, and of course it will be somewhat related to what you learn in the lab, so that is some indicative of the sort of things that are expected. But more importantly is for you to go and try to solve it on your own. And of course, encourage participation. Yes, we like people to talk to each other, work on the labs together if you want. So that would also help bring in the sense of community in a strong way. The workshops themselves. So this one, there are 3 in person. So halfway through and then towards the end, we'll give priority questions to questions that are asked through the Slack channel or to the Google groups, and that is so we can focus on the problematic areas. Of course, then we'll go over, say, the solution of the lab mainly, maybe cover some concept in the first 10-15 minutes, and then the rest will be going over the solution of the labs. So, of course, at that point, it's expected that you have finished the lab for that given week, and then we will then move on to the next week, and so on and so on. And then at that point, you will, I'll get to that in a bit, but yeah, you will submit your solution and then grade other students. Now, as already was pointed out, make sure that you do the frequent asked questions. Make sure that you go to the frequent ask question. I think somebody remotely was not muted and that created some feedback. Okay. And now the point system, we already went over it, but the gist of it is that every week you can get 20 points, 10 from weekly exercises, 10 from grading others. So you're expected to grade at least 2 other solutions. And this, in a way, would help us solve the problem of subjectivity, right? If we see that the 2 solutions are too far apart from each other, then we can bring a third grader that then will break the tie. Then points for attending the in-person workshop and then the room modes. And as what he mentioned, there will be some other task halfway through for which you could get points as well. So certainly there are many frameworks that we could have chosen to solve or to go about the workshops. But why did we choose Apache Spark? Well, it certainly has gained a lot of reception lately, and more importantly, it is a general purpose cluster computing system. And what that means is that it has high level APIs in many different languages. You can write in Java, Scala, Python, R. Some people prefer directly to write it in Scala, given that that is the language that Spark was written on. But more and more, we see that the Python and the Scala API are similar to each other, and lately there are APIs catching quite a bit. So you can do sort of very similar data processes in one platform and using one API or the other. But that is not the only way to access Spark. Also, you could do directly Spark SQL. You could write directly SQL code into Spark, and that certainly has some advantage for people that are familiar with with SQL, and it will be a quick entry point for them. And in addition to that, there are many other libraries that could be used in the process. So we have the machine learning library, MLlib. We have GraphX for graph processing, and we have Spark Streaming. In fact, Spark Streaming has been changing quite a bit. There is a new version of streaming that is called now structured streaming, and that I think is going to be the way in the future. Right now, it is in alpha, which means that it's not production ready, but certainly we saw that happening in other things like data frame and data sets that now are production ready. And little by little, we'll move more and more of having a rich set of tools, more importantly. Certainly Spark is continuously being in development. And what that means is that there is a very active community, and therefore new tools are expected to appear more and more. And some of the packages that might initially start as a user package, if they go along the lines with the Spark development, then they can be part of the main source code. And certainly one of the big advantages is speed. If you compare to other frameworks like Hadoop or Reduce, where you don't have the same advantages that Spark has, because one of the big things that Spark does is that allows you to put the data in memory, and what that means is that you can distribute in distributed memory, and what that means is that then you can have, of course, faster processing, because you don't have to necessarily load the data every time reading from disk, but directly is accessible in memory. Somewhat, we already touched upon this, is the fact that Spark is in memory. So then if you were to compare with other non-in-memory algorithms, then you would get a high performance increase. There are other in-memory frameworks. This is not the only one. Certainly, there are other competitors. There's Apache Flink, and there might be others that people are familiar with. But the general idea is that it is a highly optimized framework that you could do processing very fast. And then more importantly, is distributed. So if you realize that your times are being too slow, or you need more processing, you would scale that particular frame, you would scale your infrastructure and then therefore hopefully gain some performance there. So there's many ways that you can interact with Apache Spark. You can read from many data sources. You can read directly from HDFS. You can read from other databases like Cassandra, Hive, HBase, etc. And then inside there are all those APIs that we mentioned: Spark SQL, streaming, machine learning library, and GraphX. And then, of course, right now the supported languages are Scala, Java, Python, and R. Any questions until there? All right. Okay. Yes.
So generally, to connect to databases, is there a way to actually connect directly from Spark to the database, or we generally use Scoop to migrate the data?
You can connect directly. Yes, to the database. Yeah. Yes. All right. So what happens when you have a job that you have in Spark and you want to process it? Well, what happens is that there will be a driver that communicates with a cluster manager. The cluster manager could be Yarn, could be Mesos, or could be even standalone. So what that means is that Spark has its own cluster manager. So you don't need other cluster manager, but people use either one of those depending what sort of deployment they might have. So the driver program will connect to the cluster manager, and then the cluster manager would assign worker nodes to the driver program. And inside each one of those nodes, there will be tasks that will be executed in parallel. And then they will communicate that information back to the driver. There are many ways of accessing Apache Spark. You could do it either through a cloud infrastructure, and one of them is Databricks, and that's the one that we'll be using for these workshops. So to go to that, go to the community.cloud.databricks.com and sign up for a free account. And this account would give you access to notebooks that we'll go over. And more importantly, it would get you familiar with Spark very quickly without having to worry about setups or any other technical issues. You could run it directly if you were to download from the Apache Spark website. You could download directly the binaries and have them local in your computer. I think the only thing you require is Java and Python, and I think that's about it. Then in principle, you can start running local in your computer. And how would you interact local in your computer? There are many ways to do it. You could interact by some sort of shell. So there is something called Spark Shell, which I don't think we'll use here, but that is something that's a way of accessing. If you want to do a quick test locally, you could in principle process data like that. But you could also do use notebooks. So the one that is used often is Zeppelin. So the Zeppelin project is also an Apache project. You can find more information there. And there are other notebooks that you could also do it through Jupyter. It will require a little bit more of hands-on to set up the notebooks like that. But in principle, you could have very similar interaction that what you have with Zeppelin, or even with the community with Databricks, which is based on notebooks.
If I have a Databricks notebook, I can copy paste that code into a Zeppelin notebook, and they will work seamlessly. There
will be things that will not work because there are Databricks unique tools, but in principle, it should work. It should work. Like if you, well, one of the things, for instance, is that Databricks reads data you would have to mount the data somewhere, and where you can mount from is typically S3.
Besides data source, code is same.
The code should be the same, yeah. So if you once you have mounted or have access to your data in principle, yeah, you could run either from the code should be exactly the same. Yeah. I think we're getting to the point that we might need the wireless. How are we doing with that?
If you guys can check your Slack. Okay, so Armando, could you open up your Slack and we'll see the password from there.
Oh, I closed it.
So if you go to the channel for HackOn Data 2017. Yeah, click on it.
Okay, here it is. I'll copy it somewhere.
What's that? It's L1 associate. So if you are connected, just raise your hand. I want to see. Okay. What's that?
Oh, that's the line number. You can ignore that.
Anyone who has problem connecting to that Wi-Fi? Still trying. You will get negative points. Anyone else who has problem connecting? Okay. What's the problem? Right, so it doesn't let you. It's connected slowly, but the others connected. So if you aren't connected yet, just raise your hand. I want to see how many. Not connected. Not connected. 1, 2, 3, 4, 5, 6, 7. Armando, can you minimize that?
Okay, so
for the remaining of you who are not able to connect, use your phone and Twitter. No, seriously, I think that's a better solution than just staying disconnected. If you don't have data, tell me. You don't have data, and I'm okay. Anyone else who doesn't have data on their phone and can't connect? Okay.
All right. So for all the workshops, we expect you to submit your solutions through by publishing a notebook from the Databricks Community Edition, and we'll go over how do you go about it. How to initialize Spark? Well, one of the things that you don't have to worry about by using notebooks, or in particular the Databricks notebooks, is that you don't have to worry about initializing Spark. But if you were to, this code is in Scala, you would have to start a new Spark configuration object. You would have to do a few imports. Then you would set the application name, and then you had to set the master. The master would be the URL or the identifier of the cluster you're connecting to. But as I said, this you don't have to worry about for the notebooks. But one thing to have in mind is that actually notebooks are not what people use in production. There are people that are trying to have their full data pipeline and processing, etc., using notebooks. But what most people do actually is to write code. And how do you write code? Typically, you have some sort of IDE, and then so for instance here you would be let's go here, main, so here's where we're creating a Spark session, and then after that then you will do whatever processing you might be doing. This is all in Scala. So typically what happens is that once you have the application, you have all your code, you would package all your application to a jar file, and that jar file is the one that goes into the cluster, and that's how things are processed. Now, we'll not get to that point. Maybe at the end, if somebody has some questions on how to actually package an application and get to production, we might explore that. But our focus would be only notebooks. But have in mind that that is not necessarily the way of production. People tend to use that for more, when you're developing code, maybe you want to test something out, you want to visualize whatever is in your data set. And then from that, you move the parts of the working code into a more robust code base. All right.
This is a quick question. Which version of Spark are you guys using?
So for the workshop, we'll be concentrating 2.1, I think. I'll get to that when I put up the notebook, but it will be 2 point something, 2.1, I think. So Spark is based on a particular data abstraction called a resilient distributed data set. And what that means, what is the resilient part? It means that, say, if a job fails, that all the transformations or all the actions that you have taken on that particular data set could be recovered. So you could, in principle, halfway through your process, write up to that point whatever you have into disk, and then recover. Or if you don't do that sort of checkpoint, what you can do is directly just follow and repeat the set of transformations into the data. So from the moment you read the data up to the moment that you have a final data set. One of the things to consider for RDD is that they're immutable. What that means is that they don't change. Once you define it, they don't change. But of course, you can transform them. And when you transform those RDDs, you would create a new RDD. and they're distributed, so you could partition this RDD into many different files, and that of course then can be processed by different computers at the same time. So that is the parallel part. And it has many operations. The most used operations are map, filter, and persist. So what is map? Map takes one RDD and then converts it into another RDD. And we'll get to when you use map and when you use reduce and when you use all those in a bit. Filter, like the name indicates, means that you might filter some of the data that you have inside that RDD. And persist, which means that from that point, when you persist a data set, what you do is you bring that data set in, you load that data set into memory. So then if you were to do further operations, you would not have to read the data from disk, but it's already available for you in memory. And why is that useful is, let's say that you have a relatively sized data set. If you were to have, every time you do an operation, having to read from disk and reload, reconstruct all the transformations, you might be wasting a lot of cycles. But instead, if halfway through those transformations, you cache that data into memory, then from there on, every time you do operations into that one data set, those operations would be much faster. And what is the characterizes an RDD? There are different properties. So a list of partitions, we went over that. A function to computing each one of those partitions. List of dependencies in other RDDs. Remember that you could create an RDD from another RDD. And remember that what you're creating is a resilient data set, meaning that if you want to reconstruct a current version of an RDD, that could, in principle, contain other RDDs in the process. So you might be wanting to join different RDDs or transform RDDs. So you would have a reference to all those that were before that. Please, if somebody's remote, please mute from the Zoom. Thank you. One thing that you have with one of the big advantages of Spark is that you can directly mix SQL queries into programs, and we'll get to that more explicitly later on. But you could do things like select star from table, blah, and do projections, do joins, the sort of thing that you would be, or if you are familiar with SQL, you can directly start doing in Spark. And then, yeah, so the question related to databases, you can have standard connectivity through JDBC. There is another type of object in Spark, which is called dataset. One of the things that I didn't mention of RDD is that the contents, or so the contents of the RDD are not necessarily typed. But that is something that is solved by this new object dataset, and that was not originally in Spark, and I think this came out about a year ago or so. And then, well, what that would allow you is to do additional optimizations, say when you want, or when your particular data only access certain columns of the data and not all the columns at the same time. And it has a very rich API, and we'll get to that in a minute as well. One of the things in general when working with Spark is that the documentation is very good. So of course you cannot memorize everything that is to be learned of Spark. So what I typically do is do Spark Scala API, and then once I'm in there, let's say this Scala one here. You can have access to the documentation. So let's say if we want to find what methods are available for RDDs, we could, in principle, just come here and there you go. RDD here. And there will be some example code, but let's say if you want to know what map does, you would go here. So in this case, return a new RDD applying a function to all elements of this RDD. For more complex stuff, there will be some example code. In this case, there's, let's try to find one. Yeah, no, I know, but sometimes there are, even within the definition of the methods, there are examples. But yes, you're right. Examples are on the top. So if we say go to what a data set is, we can go here. And yes, so this in this case, there is some example of the sort of things that you can do. In this case, Spark is the entry point for the Spark API. So we're saying read a Parquet file, and here would be the location. And remember that data sets are typed. So in this case, we are saying what is the type of that particular Parquet file. And so this would be an object person, which in this case will be a case class, which is Scala. But you could do similar in Python. So my advice is always go to the documentation, have the API close to your development environment, and there is something very similar in the case of Python. So if you want to, for instance, learn more about, let's say, machine learning and let's say linear regression. So then here you have the different methods, and there are examples as well. And of course, the other documentation available here is on the Spark website. You can go to the programming guides, and there will be the quick start guide, Spark programming, Spark streaming, etc. So let's say we go to the data frame and data set programming guide, and then there will be a lot of examples. And one good thing about this is that it is shown in the 4 languages available. So Scala is, I think, selected by default, but you can have the same thing in Python. One thing to note is that the Scala, in this case, Scala and Python code looks very much the same. Of course, in Scala, you would have to define this val, but of course, in Python, you don't have that, so you just directly do df equals blah. And that is to say that the APIs, both on Scala and Spark, are very similar to each other. Of course, you have to be aware of what language you're writing on. And then if you were to see it in R, then also is available. So most things are available for most. I think less and less you see things that are only available in Scala. But certainly Scala and Python are getting very close to each other, and R, I think that at some point it will get to that point as well. So the summary, have the documentation available whenever you're developing programs, and then you will make your life much easier. So for instance, in the case of, let's go back to, say, the machine learning, and let's say you're interested in doing a classification, you could directly almost just copy the code that is in here and then use that as a baseline, and then you can start modifying on your own base code base. Sorry. And I think that's it for now. We'll get, I think maybe it's not a good idea to explain exactly what the difference between data frame, data sets, and RDD. But the idea knowing that they're different, that they have a very rich API that you can access, and then you can do transformations. And then if you have questions, always go back to the documentation. So let's go to Databricks now. So I'm gonna go here. I'm gonna go community. So this is what you find when you sign up for Databricks. There's a lot of material here. For instance, there is this introduction to Apache Spark and Databricks. So you could look at that. There's some Databricks for data scientists. This one is done in Scala. And then there's another notebook that showcases structured streaming. Once you're in it, you can go to the home, which would be your home area. And then in there, you could create folders. And so how do you create folders? You go to the tab on the top and then do create folder, or you could create a new notebook. And when you create a new notebook, you have to enter some name, and then you would have to decide what language you will be using. So let's say just for now that we're going to use the language Scala. And then at this point, I already have a cluster running. So it's going to tell me that it's going to connect to this cluster that has Spark 2.1, and it has 6 gigabytes available. So we're here ready, so we can do things like very simple. See if that works. Maybe not. Oh yeah, I finished. Nice. Let's see what else. Oh, you could see what cluster are running. So in this case, I have one cluster, and this is you don't have to pay for this computational resources, which is great. I think it's running out of AWS. And then you can see that in this case, I'm running 2 notebooks, the one that I open now, and then the one for the lab that I started earlier. If you don't have the community edition, but the regular edition, then you would pay by, I think they call it Databricks units, plus whatever AWS resources you might use. So let's get into the lab. How many of you got a chance to go over it? Okay, that's over half. That's great. So if you have questions, make sure to ask them alone as we go over the material. The idea would be starting next week. The expectation is that all of you had gone already over the material before the session start. So that way we focus just on the things that that people have questions, or that maybe we need to expand a little bit further than what you found on the notebook. So the first thing is just one other thing. In general, notebooks you could have either so you could have code, or you could have something called Markdown. So Markdown is a way of editing text and making it look nicer for reading. Pardon? Oh, how do you get to that page? Good question. Well, let's go back to that. So if you go to the HackOn data GitHub and go to the schedule ring, and then you go to the sessions, and then we're in the July 4th. I notice this says virtual, but it's in person. And then you would have the material for that session. So we have the module 1. So if you click in there, it will be a link to a notebook, and this one would include a series of videos that would help you understand the material for that week. Then there will be a lab. In this case, there is no exercise, but in some cases there will be a third link that is an exercise. And so I'm opening the lab, and this is what you would see. You would see this lab, and this is just HTML. There is nothing really here that you can execute. I mean, although it looks like code, you cannot execute this code. You would have to then import that notebook into your Databricks account. And to do that, you click on Import Notebook, copy this URL, and once you copy the URL, you go to your home, and then here, import, and then you import from a URL. And then you would copy that URL, and then you would import there. So that is the procedure that is expected every week, that you would have some, that you would import the notebook in the case that it's a lab. Then there will be guided instructions how to complete the lab. In the case of an exercise, there will be a more open blanket statement where you can work on your own. Let's see. Right. One additional consideration for the notebooks is if you go to the workshops, there is the solution submission form. And name, you would enter your name. And then you notice the next thing, it says URL to the public version of your notebook. If you notice in the notebook that I'm working on, I have a URL here, but if I simply copy and paste that URL, that is your own URL, and I will not be able to access it. And more importantly, the people that will be grading the lab will not be able to access it. So before you submit, make sure that you publish your notebook, and you publish your notebook by clicking the publish button or the publish link. And at this point, you would create a new URL that will be public. And that public URL is not executable. It's an HTML that somebody else could import if they want it. But it would render. That's what I did, for instance, to create this HTML, right? And that's what you expected. So if I, let's say, copy this location here into the URL, so that's good. And then the week number, whatever week. So I guess for next week will be 2. Now, I think I did some regular expressions there. So if you enter the wrong URL, it will not accept your solution. Let's see. Yeah, because it's expecting that particular format. So last year we noticed that people were directly submitting this URL, but remember, you have to publish it first.
That's supposed to be uploading our week 1 lab 1 notebook, or is it just for the weeks that have exercises?
Right, that will be starting next week. Yeah. Yeah, because in this one there is no material to develop. Yes. This would be a good question. I'm not sure. Yeah, just yeah. Yeah, that's true. Yeah. Yeah, this looks like Python 2. All right. Oh, so you notice that I'm now deleting a cell. There are other things that you can do to a cell. You can copy the cell, move it around, or add cells above or below. How many of you have used notebooks? Okay, a good number. So for those of you who haven't, how many of you have used MATLAB or Mathematica or one of those? Okay, so this is a very similar environment where you have a one cell, you would run that cell, and then the result of that cell will be available in the following cells. One of the things to be careful is that the variables are in a way created as you execute the cells. So if you were to run the full notebook in one shot, then it will be sequential. But when you're developing and you might be running one cell before the other and so on, you might get confused. So be careful because you might reach points where you have a variable that that was not defined. If you were to restart the notebook, that particular variable was not defined at that moment of run, but in your previous run it was, because you were running in different order. After a while, this cluster dies, and then when the cluster dies, everything else in it will do as well, meaning that whatever variables you had at that point, you would have to rerun if you want them to have them again. Okay. All right. This looks like it's not from. I gotta delete that. So we already went over some of the usage of the notebook. So what you do in here is you write Python code. In the case of Scala, you would write Scala code. So let's see. So this particular notebook is a Scala notebook, but you could still run Python code here. So let's say print hello. And if you notice, I added this particular magic is called percentage and then Python, and then I did some Python code. Similar, if you want to do things like Markdown, you would write percentage MD, and then you would do things like this is the title, and then more text here. And then it will run there as a nicer visualization. You could write math. So if you know LaTeX, you could in principle write things in LaTeX there. So the idea of notebooks is that you could in principle publish this notebook somewhere and give it to somebody else that might not be familiar with running the code itself, but they might be interested in just reading the results. So this is a way of sharing information. So in a way, making whatever you're doing reproducible. Yes. Yeah. No. So yeah, that's a very good question. The question is, if I write this particular, let's say I define a variable a equals var1. So what this is saying is that in the Python environment, I define the variable a and I give this value. Now, if I were to access the variable a in this now Scala, it would not be available.
What about RDDs or data frames?
No, they will not be available.
No, we have to recreate them?
Yes. Mm-hmm. But in most cases, people just stay with one language. So you could, in principle, write them somewhere intermediate and read from there and then bring it back. I think that would be one way around it if you really need to access that data. And then, of course, you could write directly Python code. So so what this is we're defining a variable. We're verifying that that variable is, or checking that that variable is greater than some threshold, and if so, we print. So in this case, of course, the statement will run, and this if statement will pass or will be true, and then therefore you will be printing that. We already went over that. Libraries. You can import other libraries, so regular Python libraries. So here, this is for regular expressions. But things like scikit-learn and others, other libraries are available as well, and you would import them as you would with any Python code. So in this case, also another library, datetime, and then you could directly access it there. So you could write the same code that you have available in Python. Yeah. I'm not sure. The good question, I don't know the answer to that. I will have to check on that. There might be a way. There might be a way. You can do that? Okay. Oh, okay. Even if it is not installed by default. Okay. All right. So it looks like it can be done. I'll look back in that and maybe put it somewhere in the frequent asked. All right. So at this point, you're ready to start using Spark. So the next thing would be to do a cluster example. In this case, the cluster is just one machine running. So that one machine will have the driver and the executor. So in this case, really, we're not taking advantage of the parallelism of Spark, but nevertheless, it's a good learning tool. And so in this case, we create a Spark context that is already created for you in the notebook. So you don't, if you remember that slide where we define the Spark context, you don't really have to do that because it's already defined for you in the notebook when you start the notebook. But let's say that you're running on a standalone mode, meaning that you're running on your local computer. The way to verify or to check what's the status of the cluster would be to go to a port that could be configured, but the port by default is the 4040. So we could try, maybe I won't do it now just because I think we're running short on time. But anyway, you could, if you were to run Spark in your computer, let's see, why not? So let's do here. Oh, I do have it running here. So if I go to localhost, right. This is what you would see. So this is running on my computer, and then you can see there are many different tabs. We'll go over them at some point. But in a way, this will tell you information of the current state of the different resources and the different jobs that might be running. So right now there are no jobs running, but you could use this sort of interface to do some debugging of your code. And then how do you do that in the notebooks? Well, that is also available, and yeah, I'll get to that after. But you could see it from the cell that you're running. You would have access to the different jobs associated with it. Right now, we don't have any jobs really running, so that's what we don't have access to. That debugging part, but in principle, you could access it directly from the cell. Or actually, you could also access it by looking at the cluster page. And then here, you go to Spark UI. And then you see this is somewhat similar to what I was showing you local. So then you can see that there's one job right now, and this is the job of whatever is running in that notebook. So this is the last cell that runs collect on one of the RDDs, and we'll get to what collect means in Spark context. So the Spark context would have many attributes. You could find them by just calling dir and with passing Spark context. And as I said, this is already predefined for you, so you don't have to worry about it. But you could also do things like ask for help. So help is related to objects. So this is a Spark object, but similarly, you could do help for other functions. So this one is map is a building function of Python, not the one for RDDs. But you could, in principle, just if you don't want to go to load in a separate page the documentation, you could in principle load map directly here. If you want to verify the version, you could see that we're running 2.11. So let's start with an example. So maybe I'll make this a little bit bigger. This particular data will create just a sequence. So this will be like a list. So this will be a Python object. So we will fill it with the numbers from 1 to 1,000. So this is Python code. Any questions on that? Yeah? No? All right, good. So then how do you access the first element of that list is by this way of indexing it. So, you would do square brackets at 0. And then, of course, we'll get 1. If you were to enter, I don't know, the 100th element, you would get 101. That's because the indexing starts at 0. So the 100th element would be the 101 element, actually. And then this particular range started at 1. So that's why things are shifted by 1. And up to here, we haven't done any Spark. This is all Python, so you could do things like the length of that particular list. And then, of course, this would have to match 10,000. But what we are interested is in actually using the distributed tools available in Spark. So the first thing is let's create an RDD with that data. And that data could be broken into partitions, and those partitions would have sections of the data. How do you partition becomes critical later on, because let's say that you are accessing your data based on dates. So you are analyzing, let's say, sales for one day, and then it would not make sense, say, to partition by the user ID, right? Because if all your aggregations are done only on the per date basis, you would store the data related to one day into one partition, and then the next day in another partition. So when you load the data, or when you do those queries that are mainly doing aggregations on a day-by-day basis, those queries will run faster than, say, if you had stored them on a per user, or you would have partitioned your data on a per user. Then you would have to shuffle a lot of that data, and that is I think one of the points to consider when you're building your data storage and your data infrastructure, when you're designing your data structure. We'll get to that later on, but nevertheless, it's something to have in mind, that the data is partitioned, and how do you define those partitions might affect your performance. So then each one of those partitions will be then processed by one of the workers, and then the result of that operation then will be communicated back to the driver. So one way to create an RDD is by using the parallelized method of the Spark context. So we already have the data that we defined in the previous few cells, and that data was contain a list of elements. So what we're doing here is parallelizing that particular data set, and we're saying that we want to do 8 partitions. So in this case, notice that I'm going to call this variable now xRange RDD. So this object will be a Spark object. So we were to run that, we are then parallelizing that particular data. And then if you want to, of course, have some help onto what parallelize is, you could do it directly here, but this might not be so friendly to read, so you could always go back to the documentation and then just read it from here. Parallelize. Yes, here. So here you have information, and this is what it does. Distributes a local Scala collection to a form of RDD. This is the Scala API, but similarly, you could do the same thing for Python. So at this point, this data set that was, or this data that we had stored into this list, now is it's already parallelized. Of course, this is a small data set, so if you were to run any operation into this parallel object, you might not gain much performance because it's just one small data set. But think about it, when you have a very large data set and you have a lot of resources available, you might have, what you would get, of course, the gains by splitting your data set in smaller chunks and then allocating one particular worker just analyzing that one piece of the data set. Any questions until here? Yes.
How do you know how many partitions do you need?
Yeah, good question. So that in a way depends on the resources that you have available. So if you have, so that is one, and then also depends on the sort of queries that you will be running. Yeah.
Could you repeat the question?
The question is, how do you know how to partition your data? And then the answer is depends on, of course, the resources you have. If you have a lot of resources available, then you have less restriction. But then more importantly, it depends on the sort of queries that you're running. So in the example of, say, sales data that you would have, say, an identifier by the date and identifier by the user. If all your queries are optimized by date or are related to dates, then you might want to partition your data by dates. But also, once you read the data, you could repartition it once it's in memory. So, for instance, you could that operation is called shuffle. Let's say that the original partition was something like the one shown here, but then I don't know. Let's say that you want to operate just on odds and evens. So you might repartition your data once it's in memory. So that will go to the different workers. But that operation is costly because you're shuffling data from one worker to the other. Yeah.
So it's a similar question, still about partitioning. So if I have a very big data set and I probably want to create as many partitions as possible according to my resources.
Mm-hmm.
But if I have let's say a variable type of data set, because maybe that piece of code will run multiple times in the system with different data sets, I might want to decide how many partitions and how many nodes and workers I will need every time based on the size of my data set. Because otherwise, if my data set is very small, I will have a lot of overhead work, which will make it slower.
Yes.
Is it something that can be done?
Yes, you can certainly tune the the parameters of the run when you submit the job, and that would be one of the things that you can change. Right? Yeah.
Just important to note that
Yes.
you don't have to specify partitions. Spark will partition automatically for you. It will guesstimate what's a good partition for your situation. So it's not something that you need to understand in the beginning. So for instance, if you read any data frame, it will automatically partition to 200 by default because they found it to be a good number. And their numbers are good. You need to use partitions only if you find that your data is skewed in a way that doesn't partition it properly. So usually, just let it do its work.
Thank you.
Excuse me.
Yes.
You said, as we know, Spark is written in Scala. So
Yes.
Is there a performance difference if you use a Python or Scala?
I think less and less, more and more that is being reduced. At the beginning there was, but I think more and more the performance is very, very similar. Yes, please.
There is a huge performance difference in RDD. but the data frames, the performance is equivalent. So if you're going to use an RDD object, it's going to be about twice slower in if you use Python versus Scala. But if you use data frames, it will.
Thank you. Yes.
In this course, we're using pySpark and
Yes, but we also get to use data frames. Yes. Yes. Sorry, can you repeat the question?
the data set that we find here is the range of,
Yes.
like say, if you have 84 file, how do we find that? Say like
How do you partition a file? Or the data itself could be partitioned, but that is a different sort of partition. Let's say if you have a Parquet file and it's already partitioned, but I think that is so there are two types. I don't know if I understand the question, but on a file, right, on a file. Okay, I see your question. So similar. Let's say in the case of here. So let's go to one example here, and so remember how we did Spark context parallelize? You could directly read a text file, or you could read a Parquet file, or you can read another sort of file. Does that answer your question? Yes. Oh, I see. You can then do, yeah, once you have the RDD, you could set the number of partitions as well. Here with this repartition. Once it's converted to an RDD, you could repartition it if you want it. What?
the date is one of the fields coming in data. And if you want to partition it based on date, so how do we input that partition on date and let's see what some other
The repartition functions. When you do repartition, you have repartition with a function.
Right.
That function defines the partitions, which says you'll get the partition number from this logic. You basically provide a function that returns the repartition, but it's not necessary. You don't really need to do that. Spark is when you use the SQL ones, is specifically if you're using Parquets, you'll know what to do. Because it will partition it evenly. If you partition by a date, you will end up with thousands of partitions that are very inefficient. You just load your data and sort it by date or group by date and use that. So repartition is not necessarily the best performance, best way to gain more performance. There are better ways to do that. And you can actually, instead of repartition, create a group by. Use that as your method of splitting the data. You don't need to do actual repartition. The repartition is a very, very expensive process. Yes, it's you should really only do it if you know what you're doing. It's kind of an advanced, very brute force intervention with the Spark internals.
Right.
So
Yeah.
really don't do that unless you really know what you're doing.
All right. Thank you. All right. Okay. So one of the transformations available for RDDs is map. And map, what it do is it would, as the name indicates, would map one RDD into another. So you could pass a function to this to that map, and then convert that RDD into something else. And I think this is more clear. You will see it from an example point of view. So this, for instance, this particular function, what it does is a regular Python function that would subtract 1 from the value. So remember that our RDD was an RDD that contained the numbers from 1 to 1,000. So what we're saying is for each one of those elements would map the content of that RDD, or each one of those elements would apply the function that you would pass here. In this case, we're passing the function sub, which will subtract 1 from the value. So if we were to say look at the content of that particular RDD, let's see, add cell below, so sub RDD. So let's see what happens. What do you think happens if we do that? What tells us what object, or yeah, what sort of object that RDD is. But if we actually want to see the content of our RDD, we would have to call another method. And one of the things to consider is that in Spark, because there will be some optimization done on the processes, on the transformations that you apply to an RDD, this sort of transformations are, they're called lazy, in the sense that they're not executed until you call an action into an RDD. And what a transformation or an action is, we will define later on. But in this particular case, if we simply were to call sub RDD, we won't get anything. So we will need to do some sort of action to that RDD. In this case, let's say this take 5. So this will take the first 5 elements of that sub RDD. And remember that our initial RDD started from the number 1. So in this case, the sub RDD would contain the same elements, but subtracting 1 from each one of them. And then, of course, in this case, we pass our RDD is very simple. It's just a list of elements. But you might have more complex objects, and then therefore the operations that you might do, or the functions that you will pass, will operate on each one of those will operate on a row by row basis. Actually, that's what the next cell is. That's so to see all the elements of that RDD, we can call a function collect, which will do, it will bring in the data to the driver. So the information, all the mapping that is done in each one of the partition then will be collected, and then it will be sent to the driver, which in a way is what I did when I called take into that sub RDD. So if we were to do sub RDD collect, it will then bring all that to the driver. One thing to be careful when you do this collect is that it will load the whole thing into memory. So if you, for instance, your driver doesn't have enough memory and you have a very large object, you might run into trouble there. So instead of doing collect, you might do take which is what it did before. Where if you want to examine the content of a particular RDD, that's what you might want to do instead of doing collecting to the full data set, which could be dangerous if you have low memory. Yes.
That's type collected or that's the type hit the top 5.
Pardon me? Can you repeat? Sorry.
Because does type do the collection before types the top the 5 elements?
Let's see if I understand your question. You're referring to this statement, correct?
Yeah, that's what I'm thinking.
So you're saying if take 5 is collecting the data set, the RDD? Do you know that?
So what happens is, if you just scroll down to the collect, as you can see the collect example here, it goes to all partitions and copies all the partitions into the memory. If you say take 5, it will start with the first partition, take 5 elements in as many partitions as it needs and stops. So it doesn't do a full collect, it just takes the number you ask.
Yeah, thank you.
Thank you. All right. And you can do all other operations. So the next one that we looked will be count, where you would, this particular operation will be done on each one of the partitions. So you are doing one operation per worker, and then all those operations are merged together, or those sub-operations then will be merged together to the driver later on. So then, of course, this is a very simple data set. So then if you were to count the number of elements on each one of them, we will have the same. In part is because map will do a one-to-one mapping. We're not filtering any of the elements. But in the case that you wanted to filter them, you could do so by calling filter. And then filter will receive a function as well, so similar to what similar to what we saw in the case of map. But the difference is that in this case, this function will return a Boolean, right? So whether if the value of that function is true, then that element will pass. If it's false, then of course it won't. So I think the filter function of this example is filtering elements for which the value is less than 10. So then it will go over each one of the partitions and then only pass those elements that are less than 10. So that's why only the first 2 partitions in this case have elements after the filter. Yeah, would have to, yes, yes. So the definition of that function is rather simple here. So look at just focus on the part that returns a Boolean, and then if we apply that filter onto this function, which is the function 10 that we define here, we'll only have the first 10 or the elements that are less than 10. How many of you have used Lambda functions in Python? Okay. So Lambda functions in Python are, I think they're called anonymous functions, and then similar to what we had before, in the case of this full function where it might be very verbose. You could make it in a way, in a simplified, or let's say a more succinct way. So then what he's saying with the Lambda function is that what is the input that is expected, in this case the variable x, and then the return of this function will be whatever goes after the semicolon, in this case x less than 10. So this particular expression will return a Boolean, which we could directly apply into the filter function. So notice that here with one line of code and very little code, we are accomplishing the same thing that we did with several lines. So typically, Lambda functions are used if you want to do some quickly transformation. In Scala, there is something very similar to the Lambda function, where the syntax is very similar. You don't have to explicitly say Lambda, but you could then do something like x and then x less than 10. So this would be the Scala syntax. Oh, sorry. Yes. So I think it's time for a break. We are almost there. We have the next 2 sessions. So let's take a 5 minutes or 10 minutes break. What do we have? 5? Yeah, okay. So anybody has a USB-C cable by any chance? USB-C cable. You do? Oh, thank you.
Yeah.
Let me. Yeah, good question. Let me figure it out.
And at the start of meetup, I wanted to kind of taste it. So
Yeah. What is it? What does it mean?
Civic time.
Pardon?
Civic time.
Oh.
Yeah.
Make sure at the very end, now that you have time, find your Eventbrite email when you register. If you haven't registered on Eventbrite, you need to register. That's where you need to reserve your seat. Otherwise, we won't be able to plan for the event well. And that's the only way that we do check-in. Thank you. If you can all take your seat, I know it was pretty short. We are short in time. I would appreciate if you guys, all of you, get back to your seats. We are going to start soon, like 1 minute.
How are you? Good. Can I go this part? Need the points. Oh, you're gonna be an example. Oh, so he did but it's not at all. So how did I I'm confused. Wants me to figure it out.
No, that's what I did. But I'm thinking that
Will
be
back channel. Yeah.
So we are going to start in 20 seconds. Guys, stare at that gate and people are coming late. So they will be. We're gonna go over the agenda after the break. Manny is gonna give us a quick talk, 5 minutes talk about Loyalty One and their participation in this program, the sponsorship for HackOn Data. After that, we are going to have Danny and Noah. They were graduated last year from HackOn Data, so this year they are mentoring. So Join me to welcome Manny. It's the other host. It's the other host.
Good evening, everyone. My name is Emmanuel. I've been asked to come talk to you guys about LoyaltyOne as one of the sponsors for tonight's event. LoyaltyOne is this really did not come out well. Slides are all messed up. I'll just grab my computer. Sorry about that, 1 second.
It's time, right?
That page came out. The presentation doesn't come out good.
Oh.
Yeah.
All right.
Oh, come on. Oh. All right, we'll just go like this. All right, let's try this again. All right. So, got to tell you guys about LoyaltyOne, so I can't put it in presentation mode for some reason. It's not showing up. So you guys will see my little notes at the bottom. Essentially, LoyaltyOne is a leader in the coalition and loyalty program space and customer analytics. We've been around for about 25 years. We just celebrated our 25th anniversary last month. We had a big party. We basically represent the Air Miles card. I'm sure you guys all have the blue card in your wallets. Yes? You're not earning your points properly then. You're missing out. Our parent company is Alliance Data. Again, another Fortune 500 company, also a leader in the data-driven and marketing space. I'm not going to spend too much time on this section. If you want to know more about LoyaltyOne, check our website, loyalty.com. Okay, sorry. All right, who we are within our group. So the group I represent that's coming to speak to you guys today is called Catalyst. We chose the name Catalyst because by definition, catalyst is a substance that increases the rate of a chemical reaction without itself going through a change. So our group, we've been inserted into the analytics business division, but we're still IT. We go into different groups, we help them speed up their delivery, but ourselves, we remain the way we are, and we remain as a small group, and we just go around helping people, and then we go back and do our own work, if that makes any sense. All right, cool. Myself, so our responsibilities right now are to assist the analytics team on delivering the data hub, which I'll talk about in a little bit. Myself, I've been in IT for over 20 years. I've actually been at LoyaltyOne for almost 15 years. I've had multiple different roles at this company, from a developer to a tech lead to a manager to a scrum master to a product owner. My role right now, I don't have an official role, and that's the way I like it. Personally, I don't want to be called a scrum master. I don't like the role. I do it because somebody has to. But when I want to play a developer role, I can play a developer role. When I want to play a PO role, I play my PO role, or I play my competency lead role. I play whichever role I feel comfortable with at the time. It's something that I can get away with. Not all developers can do it, but this company allows me to do it. And this is one of the reasons why I like working here. All right, so what do we do? This is what we're trying to deliver right now at Loyalty One for our analytics company, and more or less our IT vision for what we want to deliver for the data hub. The data hub is supposed to be our centralized hub. Can't think of another word. Our centralized spot for storing all of our data. So we had a data warehouse in the TISA, and we're starting to outgrow it, and we want to move over to something that looks more like this. Same types of concepts where we're going to unify all of our data in one spot. We're thinking of creating something we're calling a data lab, which was actually created by, the concept was came up by NOAA, which where we'll store all of our reusable features and have a presentation layer for the BI and analytics folks, and also have microservices on top of our data hub for all of our partners and all of our web channels to point to. This is the vision that we're trying to create. What we're doing right now is we're starting to load all of the data into our lake. We're redefining the lake and the structure of the lake. We have a bunch of data scientists within our team already that are using Python and R to create some, what are they creating? I don't remember the word. Sorry, I don't like presenting. They asked me to do this last minute. The data scientists right now are creating, yes, something else too. Lots of problems for us, yes. What is Louis working on? Sorry, I wrote it down. Recommendation engine, that's what Louis is working on. All right, so they're doing this right now in either Python or R. We have a separate team that's starting to build the analytics dashboards for our business partners. They're using Tableau, Paxata, Spark, and Databricks for all of that. And we're trying to streamline all of this to remove a lot of the repetitive work that we do on a day-to-day basis. We're trying to automate all of that so that the data scientists can get to the harder questions and start answering those. This is some examples of some of the dashboards that they're creating. Post-campaign analysis dashboard, and the last one is a partner profile dashboard. These are some of the dashboards that we're trying to automate for the business so they don't have to do this on a daily basis themselves anymore. Why did Loyalty One choose to participate and sponsor this HackOn event? So it turns out that I just found this out about an hour ago. 2 of the winners from last year's event are actually working for Loyalty One. So all 3? 3 of the top 5 winners from last year are actually working here. So the 2nd place, the 3rd place, and oh, we got 1st. Oh, I thought he said who was 1st then? No, Noah said he was 2nd. I thought I was disappointed when he told me he finished 2nd. The other guy finished 3rd. I said, why didn't we take the 1st guy? That didn't make any sense to me. But sorry. So we got 1st, 2nd, and 3rd. So if you guys win today or at the end of this event, if you guys win, put that in your resume, send that over to us, and can I say guaranteed? At least you're guaranteed a conversation. I almost guaranteed a job, and you'll probably take in mine, but figure something out for me afterwards. But we support these types of events. When we look for people to hire, we look for people like you, not people that come to work and expect the company to train them, not people who come to work and simply learn new things because the company's making them learn new things. People like you who, can I swear? People like you who get off their asses, go on their own time, take their own time to learn new things. People who are motivated, self-initiating, and really want to learn new things for themselves. Those are the types of people that we're looking for. When we hire for culture, fit, dexterity. There's some other words that she uses. I don't understand those words, but they pick all of that stuff. They pick all of that stuff before they pick experience. So just because you have 15, 20 years experience like myself, that means I can't even go out and get a job anymore. Thank you for that. They look more for people who will fit, who have the right culture fit, and who are eager to learn new things over experience. So glad to see all you guys here. That means you guys have a good chance to work for our company, because you guys are the type of people that we're looking for, and that's why we support this type of event. Cool. Sorry, say that again? Oh, I will get in trouble, I know.
So just make sure at the very end that you come to me so I can check you in. Just making sure everyone got that. Okay, Danny is one of my favorite participants from last year. He killed it, did really well. Now this year he's teaching. Join me to welcome him. Really wonderful.
Hello? Hello? Oh, can you hear me?
He works for Loyalty One now.
Okay. I'll just give a quick introduction about myself. My name is Danny Lewell. I'm a U of T math and physics undergraduate. I'm currently a co-op for Zero Gravity Labs, which is an arm of Loyalty One. And so before this, I was being math and physics. I was interested in academia, but I soon become, as most of you are, disgruntled with academia. And I wanted to try something new. So I tried data science. And one of my first things after deciding I wanted to try out data science was to sign up for HackOn Data. And last year, my coworker and I, we attended HackOn Data, and we did very well. We got 3rd place. He's currently working for Amazon in Germany. He's working for AWS. I'm working here, and we both got our jobs from the HackOn Data event. So I strongly encourage, especially students who don't have a lot of experience, this is your chance to break out. And more about the HackOn Data, Armando and Meredith will tell you how the competition works, how to get points. But I can tell you how to win. Particularly, I can tell you how to win 3rd place. That man over there, Noah, raise your hand. He can tell you how to win 2nd place. And John, where are you, John? And he can tell you how to win 1st place. So there's no shortage to the amount of people who you can get here. I was actually also here a couple months back. I don't know if any of you heard about the Toronto pySpark event, in which I talked about how to set up Spark on Jupyter with AWS. It's very, very relevant to this. If in the future you don't want to use Databricks is pretty costly. You want to set up your own Spark, a lightweight Spark on cloud. I have just a guide for you. And I've already posted that on the Slack channel, in addition to a blog post on my experiences on HackOn Data 2016, as well as my project page that got us 3rd place. Okay, enough self-promotion. Let's get started. So what I'll talk about, continue on, I'll talk about a couple other good to know Spark actions. First, can anyone guess what first does? Yeah, it will return you the first result in your RDD. So that is very intuitive. What about take? What do you think take does? Yeah, it'll take the first n elements, and you'll specify in take how many elements to take. And then you have top and take ordered. Top and take ordered. In top, when you have an order, a natural order to your data, to your RDD, top will take the top n, and take ordered will take the bottom n. And if your RDD is numbers, this will work fine. But if your RDD is something like strings, you have to specify a way to rank them. And we'll talk about that later. And finally, one of the very important functions, it's more of a concept than a function, is reduce. So how do you reduce things? It's the second part of map reduce. So it's a very important thing to know. Any questions? Good, I haven't started, okay. Yeah. No, because what you're doing here is that you're not using Python, you're using a Python interface for Spark. So everything here is really, the backend is all in Scala and Java. And so you can use Python code because this is not a list or a dictionary. This is a Spark RDD. So you have to use the pySpark API. Okay, so originally we had our filtered RDD. For those of you who completely blanked out during the last 10 minutes of the last section, I'll remind you, filtered RDD is just an RDD of numbers 0, 1, 2, 3, 5, 0 to 9. So 10 numbers, 0 to 9. And as you can see here, first takes the first element, take takes the first 4, and take 12. Even though there's only 10 elements, will return to you all of them. So that's pretty intuitive, not much to talk about there. And now we can take the 3 smallest elements, or the 4 smallest elements. So filtered RDD take order 4. So this will take, since there's already a natural order, I mean it's numbers, right? So there's already a natural order to the RDD. I don't have to specify a certain order. So take ordered will take the top 4, the bottom 4, and top will take the top 5. But if I want to now, I want to use take ordered, but now I want to specify a specific order. So now what I do, I include what's called a Lambda function. Lambda function. So this Lambda function will take an element, s, so a number in the RDD, 9 or 6, and I will send it to negative s. So 9 will become negative 9, and 6 will become negative 6. And then it uses these elements to rank it. So if you have 0 to 9, and you essentially, when you do the order, you want to take the smallest 4 elements after you apply this map. And so that will be negative 9, negative 8, negative 7, negative 6, which correspond to 9, 8, 7, 6. And that's exactly what you return.
Does it sort the entire RDD or only the 4, like only partially?
What do you mean partial?
Partial, with the partial sort to just find the first 4 elements, or like sort the entire RDD?
Oh no, this will not. The RDD is not sorted. This will just take the top 4.
Yeah.
According to that.
How does it know which one is top 4?
I think they do sort. I think they sort it. They do sort it, and then they take the top 4.
Sort the entire RDD.
The question was.
Does it sort the entire RDD or only like is it a partial sort or is it a full sort?
So when you do take ordered and I specify a Lambda function, do I do a partial sort or the full sort? And the answer is a full sort, because that's the only way you can. That's the only way you can find the true values.
No, you can't make it. I mean, take the top elements of each partition.
So
You sort per partition and shuffle the result you want to, and then figure out.
okay, so I'm having a little confusion with the question. So the question was it a full sort or a partial sort?
In a sequential environment, I mean, in an actual array, if you want to find the first 4 elements, right?
Okay.
First 4 elements which are the smallest one, you don't have to necessarily sort the entire array, right? There are
Okay.
some algorithms that you can find the only first 4 elements, right?
Yeah.
You don't have to sort the entire one. That's what I'm asking.
Are you explaining the solution for it?
I don't know how it works in Spark. That's why I'm asking.
Okay, so if you say the class.
So I'm saying if you have an array and you want to find the first 4 elements, and first, I mean, let's say smallest ones, right?
Yeah.
So you don't have to necessarily sort the entire array to find the first 4 small elements. You can find some algorithms like heap sort. I don't know, like there are some algorithms, you can use them. So I'm asking, when you do that in Spark, does it sort the entire RDD? So I want to know how expensive is this action, is this function?
I don't quite know how the back end works. Professor Mano can help me out.
Actually, that's a very good question. Anyone who knows this in details? I think you know. I think you know.
Well, it actually depends on the data source. Yeah. So Spark has on it a very smart optimizer, and it will optimize whatever it can. So for instance, if you run it on an Parquet file, it will actually use the columnar store index in the Parquet file and not store the file because it knows if this element was sorted before you did the top, it will not resort it because it knows it's already sorted. So that question is not really, cannot really be answered without the particulars because Spark has an optimizer that will do different things depending on what you have. So the short answer is it will try its best to do well. Sometimes it sucks and it needs some work. And if you want to really learn how to make Spark work well, talk to me later and I can give you some tips.
Okay.
Thanks a lot.
Any other questions? Questions that I can answer?
Guys, if you have elaborated big questions, post it on Slack. We are running out of time, so we want to move forward a little bit faster so you can get home a little bit faster.
I'm hoping to get home before 11. So here we introduce another, the last one of the 5 we saw, which is reduce. And so what reduce does is that it's a way for you to exactly what it sounds like, to reduce all the elements in an RDD down to 1, down to 1 element, or smaller elements. So in here, in my filtered RDD, I had the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And now I want to reduce this RDD, but I have to specify a reduce function. And a reduce function is a function that takes both that takes 2 numbers or 2 elements of the RDD and spits out 1. So in here, can I run this? Oh no, okay. So here, hopefully you have it in front of you, but what this will do is that this will reduce filtered RDD down by adding all the elements together. So you have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and you just start reducing them down. For example, 0 and 1, 0 plus 1 equals 1, so that will reduce down to 1. And on the other end, you have 9 and 8, so 9 plus 8 equals 17, and so that will reduce down to 17. And I'll keep cascading down until you have what number? 45? Okay. Addition is not great for a math specialist. And so you can also do the same for subtraction, but you have to keep in mind that there are some issues here about associativity and commutativity, which are just fancy words for saying that A minus B is not the same as B minus A. So you have to be careful when you're using these functions because it matters what order you reduce it in, whether it's 9 minus 8 or 8 minus 9. So that makes a lot of difference. And here, the code, unfortunately I can't run the code because I have to run a lot of stuff. So here, if you repartition these four, if you repartition them, which means you have the RDD, and then you send them, you collect them, and then you send them to different partitions again. And then you do a reduce function. This, in theory, will give a different, since this is not commutative and associative, might not give the same result as you would here. But this, since addition is the same, whether it's 8 plus 9 or 9 plus 8, it will give you the same. And so that's an introduction to the reduce function. Any questions about that?
What's the advantage to repartition before you do reduce?
Repartition in this case is just a way to show you that the way the data is partitioned will matter in a reduce function if your reduce function is not both associative or commutative, like in this case, the subtraction operator. Any questions? Okay, so here we have a way of taking samples. So here it's just a very useful function. All these functions are just useful to know, but if you go home and you try to remember what you did, you might forget them all. That's okay. Google them, Stack Exchange, API. In this case, this is just a way for you to sample from your RDD. In this case, you would take 6 samples, and here you do them with replacement and without replacement. So that's fairly straightforward. Here you can set a seed. So the seed is something that you can set, since the replacement is pseudo-random, you set the seed such that you will get the same results, the same random results each time. So you don't, so it's random, but you remember what results you got. And here we have I think run this. Okay. Here what we have is that we have an RDD of a bunch of numbers from 1 to 6, and they're repetitive. And the count by value, it essentially returns a dictionary telling you how many times each element occurs. So you have 1 here is, and this is a Python dictionary, is mapped to 4. So 1 occurs here 4 times, as you can check for yourself. And below here, let's see if this didn't work for me. Okay. And below here is I don't quite know what it is, to be honest. Yeah, I tried running this at home and I don't know what it is. It wasn't here last year, so I guess Ghost must have added it. Okay, moving on. Part 6. Okay, now more useful functions that I actually use in my day-to-day life. First is flat map. And while I could read this paragraph to you and try to convince you I know what flat map is, let me instead just show you the results of this. Okay, so here I have I'm comparing map and flat map. So first I do a map function on words RDD. So what I do is I map each element of words RDD to a tuple, the word itself and the word plus s, which is supposed to represent its plural form. So for example, cat, and here, if x was cat, it would be mapped to cat, the tuple, cat, and cat plus s. And as you can see here, that's exactly what you get. But the question also comes up, what if I want to destroy what if I want to collapse the inner structure? I don't want this tuple structure. So what I do is I can use a flat map, and this will map and flatten the structure out, such that I don't have this inner tuple. I don't have this inner tuple in here anymore. Instead, now it's just a simple RDD consisting of all of each word and its plural form. So that's what flat map does. So it maps and then it flattens everything out. Any questions on that?
If the list is nested, like more than 1 year, you know what I mean? Like stuff list, how does that?
I don't know, I think I only thought it's the first one. Anyone help me out? Yeah?
So basically, the flat map function returns the collection. So the difference.
Oh, do you want me to repeat the question?
So the question was, what do you know what do you do if you want multi-levels? So the way flat map works is the difference between a map and flat map is a one-to-one, where a flat map is a function to a collection of type X, and it will return all the X's. So if you have a collection which is a multi-level object, it will return that multi-level object.
Okay.
You can keep the microphone just.
I should get extra points for this. Okay, so here, so that was flat map. Any more questions on flat map before we move on? Okay, and here we have another one, and I can run this too. And here I want to parallelize. I'm parallelizing 2, 3, and 4. And here I'm doing a simple map. I map it to the range 1 to x. So this will map me from the range from 1 to 2. And in Python, the range 1 to 2 is inclusive of the first number and exclusive of the first. So it's really just the range of 1 and 2 is really just a list containing 1. And the range from 1 to 3 is a list containing 1, 2. And the range of 1 to 4 is a list containing 1, 2, 3. And so this is what you get if you use map, and this is what you would get if you use flat map. See, same as we did before, the structure is fine. Okay. Okay, group by key and reduce by key. So these are, I remember Armando was telling me this last year. I was learning this the last year's HackOn data workshop, and apparently every Spark newbie has to learn about the dangers of group by key. So what you do here is that you have group by key and reduce by key, and well, I'll just show you what will happen. So reduce by key, what happens when you have a RDD containing a tuple? So here, this is a tuple. It's A and 1. So the key is A and the value is 1. And we want to reduce this somehow. So I want to count the number of times. I want to reduce by A. And then I want to add up the value. So every time I see two elements that have the same key, I'm going to combine them. How am I going to combine them? Well, the key is they have the same key. How do I combine the two values? Well, in this case, they're just added, right? Here I have two A1 and A1. They're reduced down to A2. 1 plus 1 equals 2. And AAA 111 goes down to A3. And then this is within each partition. So this is a visualization of what happens underneath the hood. If you pester me more, I don't understand more than this diagram, so don't pester me too much. And then what happens here is that after you reduce it down, A1, B1, A2, B2, A3, B3, and then these are then sent again, and then they're reduced down one more time. Right? And between each partition, the information is collected, and it's reduced down one more time to have agreement between the partitions. So this is reduced by key, and as you see, it's pretty good. So this is a good way to do it. Now instead, what if I want to do a group by key? So I want to group all of these together and then reduce them. Well, in theory, it should have the exact same effect. But what you're doing is actually a bit different. See, what group by key does here is that, what it does is that it is actually has poor performance for the reason that at each stage, in reduce by key, at each stage within the partition, we were always reducing down our data. Sorry, so we were, at each step, we were minimizing the amount of memory we would use by reducing the data at each stage. But what group by key does here is that it groups all of them together, and then you do a reduce function. And this could, if you especially have large data sets, this could be a catastrophe because you're grouping all of these. There could be a lot of these entries, and you're grouping them together without having to reduce them down first. So you end up with a lot of, in the end, with a lot of data in memory, and it's going to be a lot more intensive than reduce by key. Which reduce by key at every point will reduce the number of entries such that it's easier on your Spark cluster. And just if you don't believe me, well, here we have a couple of, here we have a couple of, here we have a pair RDD, SC parallelized. So I have two things. I have three things. I have A1, A2, and B1. So these are the key value pairs. And so the first one, I do a group by key, then I map the values to a list. So in this case, I'm grouping them together, grouping all the A1s, all the things that have the same key. In this case, only these two have the same key. And then the map values is telling me, well, how do I then consider this grouped object? Well, this just tells me I'm gonna combine the value 1 and the value 2 in a list right here. And then it collects it, it just shows it. And then I can also do a group by key, but instead of collecting them in a list, I want to do some type of reduce function. And this is essentially a reduce function because you're mapping them together and you're summing up V. So this is so when you do a group by key, you get some type of, you don't get an RDD, you get some type of special grouped object, if I'm not mistaken. And then after that, you have to perform some type of option, some type of action on that grouped object, such as this one right here, which maps, what it does here is maps the key value pair, and then it sums up all the V's. And so you see here, the 1 and 2 is summed up right here in 3. And the same thing happens, you also do a map values, lambda x, sum x. So the map values, you only map the values of the key value pair. And finally, you can do pair RDD reduced by key add.collect, which is, first of all, it looks a lot cleaner, so it's a lot shorter. And we can't see the performance here, but it's supposed to be faster, and for large data sets, it is faster. Any questions on this? Yeah.
So you said use by key is always better than group by key.
I would say that probably because
So you made it. Why have group by key?
Why do we have group by key at all? That's a great question.
The reason you have group by key is because sometimes you have operations that cannot be performed through reduce. A perfect example is you have time series operation, where you want to say, I want to see all the list of events relating to my event, and I want to analyze them. So you cannot do it through reduce options because you actually want to look at the events and then sort them and then say, how did they change over time? So you're looking for a trend. A reduce doesn't give you a trend, it gives you a sum. So those are the reasons that you have a group by key. And to your question, is reduce by key always faster? There's only one time where you cannot use, where you won't see a hit on a group by key, and that's when the number of unique keys is the number of values per unique is very small. So if the number of values per unique key is small, they will be kind of the same. But if the number of keys per group is large, what happens, the problem is those lists. Because you created a huge object here that links a list per your key, and all of these objects needs to be maintained in memory as you process it. I think we just did, I'm from SWI, we just hosted a Spark event, I think in May.
Yeah.
And one of the things we did is we looked at about 5 billion rows, and we did comparison of reduced by key and group by key on a set that had many of those values. A reduced by key was about 15 minutes. A group by key failed and failed to complete after 7.5 hours. So that's kind of gives you an understanding of the difference.
Okay. Yeah.
It's like just like you say, using group by key sounds like doing the training analysis.
Right.
Yeah, I'm sure, but in case we really do training analysis, is the best method because try to minimize the key.
Yeah, there are ways to do it, and actually, when you talk about the time series, there's specific objects that are supposed to support that. There's actually a time series RDD. We're supposed to be doing that, but I'm just giving it as an example of why you need it. Another example that we had in one of our projects is we tried to convert tables into an XML. So you cannot do it. You need to actually have an object that has my key and my list of A's, and then my list of B's, and my list of C's separate. And in order to do that, we actually group by key and then join them. So you have different lists by group by, which worked horribly. But actually, what's said here is correct for RDDs. It's not really applicable for data sets if you're lucky enough to work with them.
Okay, thank you, Ian. Any more questions? Well, the next part is advanced transformations, but I see it's optional, so I'm not going to do it. In any case, it's too advanced for me. So I think in the spirit of saving time, we'll skip that. You guys should check it out. It's slightly interesting. Okay, now I want to return this to Merdan. He's not here.
Yes, thank you. Thank you, Danny. And we have Norm, who's going to introduce us the last two sections of the notebook. I think that won't be easier for you. So Noah, last session of the workshops, a lot of the solutions, he went out of his way and actually did them in Scala. So if you have Scala questions, you can always ask Noah. He loves Scala.
Yeah, definitely. Can you guys hear me? Okay, so I'll do a brief introduction, and then I have some brief content to cover. There are more tips, so I won't go very far in depth. I'm Noah. I participated last year. Like Armando mentioned, I'm a Scala user. But over the years, I've used a lot of R. So I heard somebody here is an R user. If you try to use R and you run into problems, ping me as well, and I can try to help. I have experience in both. My background, I'm a market researcher, so I'm used to working with very small data sets until recently, where I'm working with very large data sets. Now I'm at Loyalty One within the Zero Gravity Labs team, and we work with billions of rows, sometimes hundreds of thousands, and we complain that they're too small. But it's a world of difference from where I used to work, where 2,000 rows was big. Everything could fit on my cell phone easily. So that's as far as I'll go with the background. If you guys want to learn more about Zero Gravity Labs, ask me, ask Danny, go to our website. We're hiring, Loyalty One is hiring, everyone's hiring everywhere. So tips. Talking about storage, like Armando was describing, it's slow to continually read off of disk. Spark works well in memory. You can load all of your data in memory if you have a large enough cluster. And if you need to keep referencing the same RDD, then just leave it in memory. And the tip here is to cache it. So in the interest of time, I won't go in depth running all the code samples. But if you know you're going to keep reusing something, cache it. That will stop Spark from releasing the memory and putting it back on disk when new memory is used. So if you have a number of RDDs, and one cached, it will stay cached as you load in new RDDs. If you've done that, if you did persist, you can also unpersist explicitly. If you really do run out of space, Spark will do its best to handle it. But if you know you no longer need it, you can be explicit and tell Spark, I don't need this anymore. There's also get storage level or some debugging functions. You can check if you're unsure. And if you're really unsure, running unpersist on a persisted RDD won't cause a major disaster. Some tips on debugging. So this is where it gets a little interesting, and this is one of the reasons why I prefer using Scala when I'm coding in Spark. When you're using Python with Spark, you're using Python as an API, which is running code on the JVM. And it gets even more interesting when you're using Lambda functions and writing your own Python that executes on the workers. You're now running Python. You're using Python to call JVM and running Python again inside of the JVM. So it's getting weird and it's getting strange. It's powerful in that it's easy to use if you're using the high-level APIs. It's a big pain when you run into errors. The debugging messages kind of bubble up and give you sometimes errors that make no sense. There's a huge stack trace and you're running Python code. What's all this Java stuff talking about? So there's a couple of tips on how to handle that. One is when you're working interactively, just check in periodically. Don't write a whole bunch of code and then execute it. Write a little bit of code and execute it and then see what you get. On your own time, you can run this example here. There's a broken function. Armando showed it earlier. Now there's val down here instead of value. So it won't run properly and you'll get a strange error. Run it yourself and take a closer look. But the point here is to take a little bit of time. What Armando was explaining, RDDs are lazy objects, which is good for a number of reasons. It makes them resilient. They're basically a set of instructions on how to recreate the RDD itself. When you do a filter, when you do a number of transformations to the RDD, nothing happens. It just increases the list of instructions on how to execute and create that RDD or recreate it. You have to run an action for it to persist in the first place, but also to find out if there was a bug in that map function that you were running. You do have to run some kind of action. What they're recommending here is you run collect. I'll deter a little bit from that. Collect it'll basically leave Spark. If you run collect, it will bring it in memory. In this case, it will bring it in memory as a Python object. If you're using Scala, it would just be a basic Scala collection. Instead of doing something as heavy as that, if you have billions of rows and you only have a little bit of memory on your driver, it will attempt to pull all of those billions of rows onto your driver, and you'll run out of memory and it will crash. What you can do instead is a little lower energy, so to speak, action. Just run a count. So if you're exploring and iterating in your notebook, do some transformations, one, and then run a count on it. If it worked, awesome. Then do another one. Do another transformation, run a count on it, do another transformation, so on and so forth. And what that will do is it will help get around the issue of the cryptic JVM stack traces. When you do run into an error, you'll know that little transformation you just did was the cause of the error. So it's a little bit on you to go through that method. What they're describing here is code style. It's not the best thing to do in production. It's when you're iterating and exploring within your notebook. In production, what you'll want to do is run all of your transformations and then run the action when you need it. But when you're exploring, there's no issue. Transformation action, just for your own safety. And the last point here is readability. If you are sequencing or chaining, in this case, a number of transformations before you run an action, here it's collect on the end. Wrap them in brackets and put each transformation on a new line. It makes it easier to edit, it makes it easier to read. It's just better style overall. So that's it for tips, a few quick ones. If you guys have questions, feel free to ask. I'm on the Slack channel, so I don't always follow day in, day out. So if you need me specifically, just send me a DM. Yeah, go ahead.
Difference between persist and cache? I didn't get that.
Between what were the?
Persist and cache.
It was unpersist was the one I was mentioning. I believe they're the same. There is an API that lets you specify a little bit more detail of the type of caching you'd like to do. And I think that would be persist lets you pass in a little bit more. Yeah, it's slightly, let me see here. It was listed there just a second ago. It's a minor difference. If you look at the API docs, it'll explain exactly what it is. But cache is persisting, but with a default setting as far as I understand it. Persist lets you actually be more granular yourself. Cool. Well, thank you for your time.
So, Armando, is there anything that you would like to add?
No, I think the question that keeps coming up is what is due for next week and when is the material release? So the material for next week will be released tomorrow, and whatever is in there, so the lab or the exercise that will be released tomorrow is due next Tuesday, end of the day. And why is that? Is because we'll go over the solution in the session, and then after that, then we'll pass it along for grading. So tomorrow, I think tomorrow night, that's when I'll release the material, and then you'll have for next Tuesday. You were expected to submit next Tuesday, end of day.
So before the session starts Tuesday, we have to submit it.
End of yeah, I guess so. Yeah. End of the yeah.
Not after the session.
You could, but there will be a part. There will be a part that we won't necessarily go over the session. The session will cover the lab part, but if there is an extra exercise, we might not cover it in the session itself. But yeah, that's the idea. I mean, we understand that people have their own work and their own occupation, so it might be tight on time, but yeah. You couldn't first of all submit late, but there will be a penalty, right? And that.
Some people have other trainings of yours to them.
Yeah. Okay.
So, thank you so much for coming to this event. You are definitely an actor who will make it.